Greetings and welcome to week 3 unit 3 on concept maps and mind maps. In the previous unit we understood the role of instructional components, analogies, metaphors and graphic organizers. In this unit we will try to understand the role of concept maps and mind maps in instruction. Actually, concept maps and mind maps are also graphic organizers. Sometimes they are called advanced graphic organizers. There are many more advanced graphic organizers. Some are less structured, some are more structured. For example, mind maps has very little structure, whereas concept map is a little more structured. There are certain rules to follow when you organize that. Still more rules like topic maps and so on, or argument maps. These are all advanced graphic organizers when you present. Okay, they are used in very special cases when you work on some multidisciplinary projects kind of thing. We kind of try to recall, as we said, under revised Bloom's taxonomy, which is two-dimensional. One dimension is cognitive processes, the other dimension is knowledge categories. And the knowledge categories that we are concerned in the revised Bloom's taxonomy is factual knowledge, conceptual knowledge, procedural knowledge and metacognitive knowledge. To this we added Vincenti categories of engineering knowledge, which are 4 again, which can be added below. But right now for us we will limit ourselves, because we are limiting ourselves to only one variety, namely conceptual knowledge. Actually a course, whatever, because predominantly in our higher education system, which consists of a number of courses, each course is organized as per conceptual knowledge or a procedural knowledge or a combination of conceptual procedural knowledge. Depending on how you want to organize your course, you can correspondingly create a map for that, a graphical map. We will be talking about the concept map. That is, how do I, if I look at my course strictly in terms of the concepts that are important or part of that course that a student has to master, then we will try to create a map only consisting of concepts, not the procedures. Okay. If you want to create a procedural map, yes, that is a different exercise. We are not looking at that. We are looking at concept map, and if you want to integrate procedural dimension also into that, that is a different exercise. We will confine ourselves to map only the concepts. Concept map is a graphic tool for organizing and representing conceptual knowledge. Simple. How do I organize the conceptual knowledge that I have to impart in my course? When I am talking about a course, I may already have in my mind which are the prerequisite concepts that the student should know. Okay? So we start from there. The student should be knowing these concepts, and from there I try to build. So we are only representing the conceptual knowledge that one is presenting in the selected course. And incidentally, in this if you go to this particular site that is shown, you can get the tool. We will explain more about the tool presently. The concept map includes obviously the concepts and relationships between concepts indicated by connecting a line linking two concepts. If one is dependent on the other, we will show by a line, and then when you connect a line, how they are related to one another, we use a linking phrase. If I write a linking phrase, then what happens when I read how concept A is connected to B, I put the linking phrase to make it into almost like a sentence. We will presently see how the linking can be shown. So, how is the concept map organized? The concepts are represented in a hierarchical fashion with the most inclusive, most general concepts at the top of the map and the more specific, less general concepts arranged hierarchically below. Okay. This hierarchy is strictly with regard to the course that you are considering, and it has nothing to do with what do you call the difficulty associated with that particular concept, in understanding that particular concept. For example, unless I understand concept C, I cannot understand B. B may be simpler than C, but unless I know C, I cannot understand B. That is the way hierarchy would work. The hierarchical structure for a particular domain of knowledge also depends on the context in which that knowledge is being applied or considered. For example, a teacher may consider, though certain concepts ought to be clear to the students, let us say in high school time or in a previous semester, but you are not sure whether the students properly understood that. If you want to bring that also into your course, that is your choice. It depends on the time available to you, what in all the concepts that are associated in your course, which one do you consider more important or where more time needs to be spent. That is all the choice by the teacher. Construct concept maps with reference to some particular question we seek to answer, called as a focus question. It is not just arbitrarily linking variety of many concepts together. Ultimately the course has certain purpose. That final purpose, if you can convert into form of a question, it will tell you what is the most important concept or the highest concept that you are trying to achieve. So, if you can write down your focus question of a course, which can be, let us say, like we write our course outcomes, you can say what is the aim of the course, one sentence. If you can write, maybe that will help you to convert into a focus question, which will help you start preparing your concept map. Okay. And concept map is not only used to graphically represent the relationship between the concerned concepts, it can be used for a variety of other things in instruction. One, to generate ideas, brainstorming. You can use concept map to brainstorm. That is, you can take a piece of paper and keep preparing a concept map. To design complex structures, when you want to write a long text like a complete report, 20-page, 30-page report, then you want to have some structure to that. So, in that case you can also that structure can be represented using a concept map. to communicate complex ideas. That also, if you prepare a concept map, one can present. We will keep using this concept map in our course later as well as in associated courses. To aid learning by explicitly integrating new and old knowledge. I can write a concept map in such a way, the old knowledge or the prerequisite knowledge, I can draw a line and say the concepts below are the prerequisites. I can create a concept map like that. And to assess understanding or diagnose misunderstanding. If I ask students to prepare a concept map for something, that is his way of answering that, and I can check his answer or look at the concept map he generated, and I can possibly diagnose if he has misunderstood something. Okay. So concept map can be used for a variety of purposes. Now, prepositions used in the concept map, we have a large number. It is not necessarily restricted to this. You are using a phrase like is, are, as, have, or any of these simple things, or consist of, include, begins with, or it absorbs, requires. A variety of phrases can be used, and you need not be restricted to these phrases alone. You can judiciously even coin your own phrases to link concepts. For example, this is a concept map created for design and analysis of algorithms. We will return to that later. If you look at this algorithms is a concept, and here whole number of concepts are there in this. So what happens, algorithms are related to this bunch of concepts here. Okay. We call this as an object, that is this either a rectangle or a rounded rectangle that you have here. One way of looking at it is one object can only represent one concept. But if you want, then you have to spread your concept map very wide. If you want to do that, you can put multiple concepts in the one box, but you cannot put a procedure inside a box like this. You have to restrict yourself only to concepts associated with that. Okay. So here, for example, algorithms can be greedy algorithms. That is the name given. There are a variety of algorithms. They can be greedy algorithms or divide and conquer algorithms. Again, if you look at, you have one concept. There is a link here. It is a link to that, and you have a linking phrase. Linking phrase here is can be. Algorithms can be greedy algorithms. Algorithms can be divide and conquer algorithms, or it can be dynamic programming algorithms and NP complete and NP hard algorithms. Okay. So you have, when you have one connected to so many of them, I can use this. For example, I can put all of them together in one box and say algorithms can be any of them. It depends on if you want to integrate, because if you want to integrate like this, the way it is shown here, so many of them at the same level, I can put multiple concepts in this, or one concept in one which I want to further elaborate hierarchically. It is like this. Okay. So here algorithms are characterized by, they have a need. So need is one concept, efficiency is one other concept, like that. These are all the what do you call characteristics of an algorithm. each one is a different concept. I suppose I have explained the structure of a concept map which will have all these elements. In the map we call this as an object, a square or a rounded corners with that. You can also use a square, or you can use a oval shape or a circle. You can use any of them, there is no restriction on that. The tool actually gives you a choice also, and what kind of color you want to use, all that is there available in the choice. How to draw this line and where do I put my phrase, all that is given by the tool. Okay, you do not have to struggle. It is actually one of the more simplest tools that I have ever seen, the Cmap tool. If you open it, you will just get a blank page and tick something, one box kind of appears. That is where you start. It is a great experience to draw a concept map for your course. I can assure you, all faculty, wherever we tried doing this, they have really enjoyed. But once you start drawing a concept map for your course, it takes considerable time. You have to be patient, because you are now viewing your course from it looks like, my experience is, having worked with at least a few hundred faculty trying to draw concept maps, it is a completely new experience for them, but it takes time. But eventually after a few hours they get that and they feel thrilled. They are saying that, oh, this is my course kind of thing, this is the way I need to understand my course. Okay. So we assure you, you please try please try this exercise of drawing concept map for your course, and it is always better to do that with the help of your colleague who is also familiar with the course. If minimum two people can sit together and draw it, you are likely to get a much better concept map. Now, one is we explained the idea of a concept map, but we want a tool also to draw that, not keep on struggling with a pen and with a paper and pencil and keep erasing, drawing this, redoing the line. And you have Cmap tools, and it is one of the very long lasting, somewhat in similar form. The tool was made public in year 2000, and they are continuously improving the tool. Right now we have 6.04, and it is free. Though its size is large, one can just freely download that and start using within few minutes of wanting to do that. Okay. Cmap tools is a widely used concept mapping software developed by the Florida Institute for Human and Machine Cognition, IHMC it is called, and the tool is developed there, software tool is developed there, but the idea came at the Cornell University. It is a tool designed to help users construct, navigate, share and criticize knowledge models represented as concept maps. This has been extensively used at school levels, but the map itself is not restricted to school levels. The idea of concept maps originated in the 1970s with Joseph D. Novak at Cornell University as a tool based on Ausubel's theory of meaningful learning. In the 90s, Dr. Alberto Canas and a team at IHMC began developing software to bring concept mapping into digital platforms. This effort led to birth of Cmap tools with the intent to support knowledge construction, collaboration, learning and educational assessment. So all the three you can do. The current state 6.04 if you look at. It is available on platforms including Windows, both 32-bit and 64-bit, Mac operating system and Linux. The present version provides enhanced usability and AI integration. It is free and can be downloaded from this particular place. From this link you can directly download. Please download, it is free. It may be about 100 MB size wise, but it is really worth exploring. Now the core features of 6.04: create and edit concept maps using drag and drop linking concepts with labeled arrows. Okay, I have shown you what a labeled arrow is. The arrow need not be one straight line. It can be bent at multiple angles, it can be curved one. Cmap tool will allow you to use any kind of multiple types of lines to connect one concept to the other, because if you have to go around something you require a curved one also. Edit maps synchronously with online peers. Two or multiple people can work together from multiple locations on the same map. Each one can try to modify that. Embed external resource. This is one very interesting one. As we said, one concept or a number of concepts are represented or put in one box. Okay, one box representing multiple concepts. With that you can link images, documents or PPTs or web links, anything you can do that. In fact, if you are willing to adventure that way, you can integrate your entire course notes or whatever you want to do onto the concept map. It will become a big file obviously, and you can keep navigating through that. In every class you open the concept map and you can say where you are, show where you are, where you came from, and then whatever links that you have, documents or PPTs that you have created and linked, you can open that and present it in the class. It will be an interesting experience to do that. Export maps as PDF, JPEG, HTML and XML and other formats. Multiple predefined templates for quick map creation, and search for relevant information directly from within the tool to enrich a concept map. I myself have not explored all the options that are available, but whatever limited things that I have experimented, it was really enjoyable and very useful. That is why once again I strongly urge that you use this concept map to create a map for your course. And mind you, while it is called Cmap tool, but Cmap tool can be used for doing many other things as well. So we call it Cmap tool. For example, I can use the Cmap tool to create a mind map. Okay, I can do that. Now here is my favorite map for electromagnetic theory, which is incidentally is a compulsory course for electrical and as well as electronics students, and which is a course many times neither the teachers nor the students like, but it is compulsory for all. And this was created by one Professor Abhay Kumar, who was the principal at Tyagarajar College. This was done already about 10 years ago, but it is so well done. I continue to demonstrate what a concept map can do. Okay, the course is related to electrical charges. Let me only trace one branch. the other branches you can follow. Electrical charges, and here as you can see it has multiple levels hierarchically. Here the number of levels is large. If you look at 1, 2, 3, 4, 5 levels are there. Normally we say do not cross 4, but if the map is not cluttered you can go a little more, but it is better to keep it at 3 to 4 levels. Okay. Now electric charges can be static charges, moving charges, or accelerating charges. And here if you look at moving charges, they produce currents, and currents produce magnetic fields. Magnetic fields are characterized by magnetic flux, flux density, magnetic potential, energy, and energy density. All these are concepts associated with magnetic fields. Okay. And magnetic fields principles are applied to the study and design of cathode ray tube, motors, generators, and magnetic brakes. And here these any of these properties are determined by Biot-Savart's law, Ampere's law, Curl's, Stokes' theorem, and Faraday's law. So you use all these laws to determine these properties. Now you can trace the other branches similarly. As you can see, you can traverse through this. If you feel comfortable in traversing, then I think you have drawn a good map. Okay. Now if you look at magnetic fields, principles are applied to the study and design of this. For example, in your course you may not want to look at all these 4, or you may want to look at something different. So change them. So you can convert this, if you are teaching electromagnetic theory, you can modify this map to suit your the scope of your course. Okay. But what is fascinating is it is mainly about electrical charges which are static, which are moving, and which are accelerating. That is what it is. Now we want to, these are my suggestions when you prepare a concept map. Keep the number of levels to 2 to 4. Then we showed you the algorithms which has only 3 levels. Keep the number of levels 2 to 4. If the number of levels needs to be more than 4, use multiple maps. If you consider one particular concept, it has to be elaborated more, then draw a separate map for that. So that way the main map does not get cluttered. When you come to that, you switch over to the other map and keep coming back to the original one. Organize the Cmap without any cross links. What it means is, let me go back to this map. If I draw the map in such a way, when I am dealing with this, I have to somehow link it to this all the way here into the first branch. Then what happens, you will get cross lines along, and then it will be very confusing. What we found in all the maybe 200 odd exercises that we have done, if you are careful, very rarely you will require to draw a cross link. You invariably do not have to draw cross links if you think of your concept map properly. Okay. It should be clean like this. And now with the idea of your course outcomes, let us say which are about 6 to 8 for the 3 credit course that we normally do. In that case, it is preferable to keep the number of branches equal to the number of course outcomes. If it is, but it is not a hard and fast rule. If you think some concepts they go across, you have to do slightly differently, you are welcome. In many cases, the branches can be organized in the same sequence as that of course outcomes. That means you are traversing from left to right, which also sometimes represents the progress of the course in the classroom. Occasionally, it may not represent a time sequence, but in most of the cases we found it kind of follows the sequence. Take a look at this. This is a 3-level, including the top one, it is a 3-level map, and like here if I put numbering here, so this will be the first one and you have 6 equivalent of 6 outcomes, let us say course outcomes, and the time taken for each one need not be equal. There is no need for that. It is not unitization. And if you want to consider greedy algorithms after you look at divide and conquer algorithms, you are welcome. You can shuffle that. Okay. So you can convert into your own map like this. So there are no cross linkages. It is a 3-level one, and each level can be seen very clearly. Links between one and the other is also clear, and for example, the Cmap tool will easily allow you, let us say I want to shift this greedy algorithm here and this one there. It's a very simple what do you call editing mechanism that you have. You can shift the entire thing to the other side. Okay. Now that is about concept maps. We have another kind of tool which is, we call it what do you call, instructional component, note making and summarization. Actually, note making and summarization is a sub process of our understand category of Bloom's taxonomy. Okay. This is a process by which your students discover the big picture and the main points from their learning. For example, doing a précis or making a concept map or a mind map at the end of a topic, creating graphic representation, anything that you do. So that means after listening to something presented by the teacher can ask them to either prepare a note or summarize. This note preparation or summarization can be purely text form, like we use the word 2-minute paper. In 2 minutes you have to write something, or you write about 10 sentences, something like that you can specify, or you can ask them to prepare a kind of a graphic representation of what you have understood, or actually prepare a concept map. So all this comes under note making and summarization. Notes made by the learner are more effective than copied notes and books. This is the best way. If the teacher keeps on writing on the board and students merely copy that, you do not learn. If the teacher explains something with using whatever it is and ask them to write a small note, that will be most effective. Okay. And 2-minute paper is an example of summarization. This is something that is practiced by some faculty. 2-minute summary. That means only 2 minutes are given for the students to write on a piece of paper. If you have some tools, they can type it out also on cell phone and share it commonly with the teacher. Teacher can immediately see at least some of them. The teacher can design templates for his proposed activities for note making and summarization. To make it easy and faster, you can make what do you call, some templates can be designed and shared with the students and they can work on it. Visualized note making is a strategy that encourages students to associate language with visual imagery. Okay. So that is, you show an image, ask them to write some features of that. Teachers can encourage students to link verbal notes with images, symbols that show sequence, patterns and relationships. ICT tools today can be used to make this engaging activity efficient, because efficiency also matters because you have limited time in the classroom. Now we come to another graphic tool or graphic organizer, or called it advanced graphic organizer, called mind map. Mind map is a visual tool used to organize and represent ideas, concepts and information around a central theme. This is, as I mentioned, it is not as structured as concept map, but it is a little wild. Let us say you start with some central theme or a concept, and whatever that comes to you, you keep connecting it to that in any direction, or any kind of arrow you can put, or any picture you can link, or you can write a text, do anything like that. It uses branches radiating from a central node with keywords, images and associations arranged in a non-linear, hierarchical and interconnected fashion. We will presently show an example. Mind maps are powerful visual tools for the teacher to explore along with the students in the classroom relationships between and among parts of a key idea. You can even physically draw on a whiteboard with colored pens. You can keep, as the students respond, you can keep drawing on the board. This was proposed by Buzan in 1989 and it is popularly used even today. So here mind map, it is a sample one of emotional intelligence. So one can draw like this. You can you have maybe a library of small images or icons like this, and you can keep drawing. For example, let me show one branch. Emotional intelligence. What is EI? That is emotional intelligence. You try to say what is it, and it has a structure that is given, which we will explore in another course, how it is organized. Okay, are benefits of emotional intelligence. You have personal well-being and at work, and at personal well-being it can be any of these, and at work it can be any of these. You can show whether you use a graphic symbol like this or not, that is your choice. Okay. So you can somebody had patience to put all these symbols, and if you have, you can spend a little time and really create an interesting, it need not be for an entire course. It can be what you consider as a core idea. From that core idea you can create a concept, a mind map like this. Okay. What are the key characteristics of mind maps? Central concept in the middle, branches represent main ideas or categories, sub-branches show details or related ideas, uses keywords, symbols, colors and images. If you can use, emphasizes relationships and hierarchies. Okay. That is what the characteristics of this. And why should we, what is the use of using mind maps? Boosts visual memory and recall. Anything that is visual information that is presented, we seem to be recalling more easily. Encourages creative thinking, enhances conceptual clarity, aids active learning and promotes metacognitive awareness. If you are able to draw a concept map or a mind map like this, it promotes metacognitive awareness. And tools for this, you have some are professional, some are free tools. Cmap tools is free. You can use Cmap direct. If you are drawing Cmaps, you can also, using the same tool, you can draw the concept maps as well. There we will not talk about hierarchy, they are all radiant. The central idea sits at the center and everything branches in all directions. You have MindMeister, XMind, Miro, Free Mind, MindView. These are the tools available. Some are open source and there are some free and professional versions are also available. And now you can look at mind maps from a student's perspective or from a teacher. For students, they can use the mind map as a note taking tool as he or she understands the relationships among parts of the idea under consideration. When the teacher is presenting something, the student can, on a piece of paper, can try to create a mind map. Preferably use a pencil and an eraser to keep correcting it. If you are by the end of the maybe a session, if you are able to create your own mind map, that represents your understanding of the idea that is being presented. The mind maps also allow students to look beyond the obvious, make inferences and discover new knowledge. Sometimes you see a branch and somehow the branch is not completely addressed in the classroom. If you have any ideas, you can extend the branch. That way you are discovering new knowledge. Whereas teachers in class begin a lecture with a collaborative mind map. That is, combining with the students, you draw a mind map. That is how you introduce your concept, either using a software tool or drawing on the whiteboard. You can give it as an assignment. Ask students to submit mind maps of a topic for evaluation. Or you can do, while doing a project, use mind maps in the early phase of project development or research proposals. You can use that. And then it keeps getting structured, more structured as you proceed forward. Like then you can create a storyboard after you do the mind map. And it can also be used in assessment, both for diagnostic misconceptions based on connections or omissions in student maps. By looking at that, looking at the mind map created by the student, you can assess his understanding. So in the next unit, we will look at the use of portfolios, learning journals and reflection journals. Thank you for your attention.